Now, if the world wants to stabilise global warming to 2 degrees by the end of the century, how are we going to do it? Well, here's one new idea. Trains pulling special railway wagons built to suck carbon dioxide out of the air. That's a serious proposal laid out in detail in the Sustainable Energy Journal Joule this week. Even with drastic reductions in carbon emissions, the International Panel on Climate Change says that many gigatons, billions of tonnes of CO2 need to be taken out of the atmosphere to prevent the worst climate change outcomes. There are various ideas on how to do this. Planting vast areas with trees is one, but another is called direct air capture. This would entail building industrial plants that use technology and chemistry to extract carbon dioxide from the air, compress and liquefy it, and then keep it out of harm's way by, for instance, pumping and sealing it deep underground. Toronto University chemist Geoffrey Ozin outlines how this would work.
In order to collect the air, one needs many very large fans to basically grab the air. And then you need a type of a filtration system, which is either a liquid or a solid. We call them adsorbents or absorbents. And these liquids or solids basically have to capture the CO2, which we call adsorption. And that doesn't involve any energy. That's a spontaneous process. But then we have to desorb the CO2 from these materials. And this is where very large amounts of energy are required. So you need energy to drive the fans, and you need energy to drive the desorption process. And then, of course, you've got the energy questions of compression, liquefaction, and storage, either in cylinders or piping it to whatever you want to do with it. And so, there are estimates that if you want to scale this to the gigaton scale, you're going to need millions of these land-based direct air capture plants. This has been estimated to require something of the order of 25% of the world's energy supply, which at the moment is not exactly green. It's of the order right now of 10% renewable. And the land area is estimated to be really quite large, obviously, to do this.
Which brings us to the idea of running direct air capture operations in specially designed freight cars, literally running them on railway networks around the world instead. There'd be no need to build all those new plants Geoff talked about, and you wouldn't need giant energy-hungry fans to suck in the air.
If you build these direct air capture systems inside a freight car, which has a collection vent as it's moving, which means that the air is basically moving into the freight car through a vent at the speed of the train. Clearly, we do not need fans. So that's one of the energy advantages. And then we have to take into account that if you then basically have a direct air capture system, which adsorbs and desorbs the CO2, and then it is compressed and liquefied and so forth into stainless steel cylinders. This can be then delivered along the track, somewhere along the railway, to tanker trucks or to pipelines and so forth for sequestration underground, or use it for making commodity chemicals and fuels.
As Geoff Ozin said earlier, the most energy-hungry part of the process is forcing the CO2 out of the materials that have captured it and into a form where it can be liquefied and stowed. But according to Eric Bachman, who's founded a startup company, Co2Rail, with the aim of realising rail-based carbon capture, there's plenty of free energy on board every train to do this. If the train is equipped with so-called regenerative braking technology, every time it slows down or stops, this converts the train's hefty forward momentum into electrical energy.
With a train, when the engineer engages the train's energy braking system, the locomotive's electric motors are used to convert the train's forward momentum into electrical energy. This electrical energy generated during a stop is often enough in freight to power 20 or more average homes for an entire day, is then passed back to the Co2 rail car and is used to recharge their huge battery arrays.
So the energy, that, if you like, that's harvesting from the braking process, it's not wasted as it might normally be with a regular braking system and kind of lost as frictional heat. You're actually, in this system, you're converting that energy into electrical energy, storing it on board in batteries, and that's essentially what you're using to keep that carbon dioxide or process that carbon dioxide in these specially designed wagons.
Yeah, apart from a very small amount we get from solar panels mounted atop the cars, it's 90 to 95% powered by the regenerative braking system.
And you would harvest this energy every time the train stopped or slowed down, any time it was using its brakes.
Yeah. So we anticipate equal use between freight and passenger operations. As you can imagine, a freight train is much heavier than a passenger train. However, a passenger train does have the advantage that it stops a lot more frequently. So while during every stop, it will have a smaller amount of energy production, it will have many more of those stops per day versus a freight train that has much more energy production, but fewer stops.
And what kind of calculations have the two of you done to get a sense of the kind of contribution that this could make to getting that carbon dioxide out of the air, mitigating climate change, global warming?
Well, that's a big question. It depends how you want to break it down. On a per car basis, our midterm target, 5 years to 10 years, is 15 metric tons per day.
That's how much carbon dioxide one of these CO2 capture wagons could take out of the atmosphere.
Correct. That's our midterm target. Some trains are heavier, some trains are faster, and all that enters into the equation. But on average, our midterm target is 15 metric tons per day.
I mean, potentially, there's a lot of railroad around the world to leverage here, isn't there?
There is. Little known fact is if you took all the rail that exists in the world and laid it end to end, it would reach to the moon and back twice over. And then if you want to look at the equipment side, if you couple every rail car and locomotive that exists on the planet together, that train would circle the globe at the equator nearly 4 times.
With your vision, then, is it that, you know, in the ideal world, there would every train that was traveling somewhere in the world would have one of these trucks on board taking carbon dioxide out?
Obviously, that's a really high hurdle to get to, but what I can say is nearly every train in the world is wasting this, what's currently called dynamic braking energy. So if at all possible, we believe it's far superior to utilize that energy. And I personally can think of no better way to utilize the energy than removing carbon from the atmosphere. Realistically, if we target the top 10 rail countries in the world, we'll make a big dent in CO2 concentrations over time.
Eric Bachman, and he expects the first prototype direct capture freight car to be built early next year. A vision worth watching.